Okay, so we have here a circuit and we are asked to use nodal analysis to find V1, V2, and V3. So let's start with assigning voltages. So we have here V1, V2, and V3 and assume direction of the current. So we have here direction of the current downward since it is connected to the ground. Then for the current here, so we have here a voltage source 12 volts and its polarity is positive negative. Therefore, it flows upward. So it enters the node V3. And then for the current that flows through 8 ohms, so it is flowing to the right. So let's assume that is to the right. Okay. Also for the 2 ohm here, so it's to the right. Then, let's start with creating nodal equation, starting with the V1. So, in nodal analysis, as you can still remember, so it used the principle of KCL, so current entering. Okay, current entering is equal to current leaving, or the summation of current in a circuit is equal to 0. So I entering is equal to I leaving. So at V1, so let's look at V1. The current that enters to this node is 5 ampere only. And that is equal to current leaving. So we have V1 over 4. Plus, we have V1 minus V2 over 8. Plus, we have V1 minus V3 over 2. Because this is the same node. Okay. And plus 3. Then let's multiply both sides of the equation by 8. So we'll have 40 is equal to 2v1 plus v1 minus v2 plus 4v1 minus 4v3 plus 24. So 40 minus 24 is equal to 16, equal to 3v1. May 4 pa. So this is 7. We have 3 plus 4. So this is 7v1 minus v2 minus 4v3. And that is our first equation. Then for node v2, so let's look at the node v2. So this one, current entering the node v2 is v1 minus v2 over 8 equal to the current leaving, which is equal to v2 over 2 plus v2 minus v3 over 4. And again, let's multiply both sides of the equation by 8. So we have v1 minus v2 equal to 4v2 plus 2v2 minus 2v3. Then v1 minus 1 minus 4 minus 2, we have negative 7v2 plus 2v3 equal to 0. And this is our second equation. Then for node v3, so let's look at the node v3. Current entering, so let's start with 3 ampere. So we have 3 plus v1 minus v3 over 2 plus v2 minus v3 over 4. Then plus this one. So of course, you have to consider the 12 volts. So 12 minus V3 over 8. And there are no current leaving to this node. So this is equal to 0. Then multiply both sides or just the left side because right side is just 0 by 8. So we'll have 24 plus 4v1 minus 4v3 plus 2v2 minus 2v3 plus 12 minus v3 is equal to 0. And we'll have 36, okay, plus this is 4b1, then 2b2, and negative 4 minus 2 minus 1, negative 7b3 is equal to 0. Therefore, our third equation is equal to 4b1 plus 2b2 minus 7v3 is equal to negative 36. So that is our third equation. Now, to find the value of V1, V2, and V3, we have here three equations, three unknowns. So, you can actually use matrix or Kramer's rule to solve this. But if you want to just use calculator techniques, so just use mode 5-2. So, mode 5-2 is the equation for three unknowns, and you'll find the A, B, C, D there. You have to enter the three equations. Okay, so I have already discussed this with my other videos. You can just check it out, nodal and mesh analysis. So this is mode 5-2, and you will find the answer. Our V1 is equal to 10 volts, V2 is equal to, what's this, 74 over 15 volts, or that's also equal to 4.933. Yan. Then V3 is equal to 184 over 15. And that is equal to 12.267 volts. And that is our nodal voltages. Now, if you want to use nodal analysis, short method or short technique, so I will also teach you here. So, same circuit, we have V1, V2, and V3, okay? Then, we'll start with creating nodal equation. So, at node V1, you're going to look for the resistors that are connected with this node. And we have here 4, 8, and 2. Therefore, this will be V1 times 1 over 4 plus 1 over 8 plus 1 over 2. Then, look for the nodal voltages that has common resistor with the node V1. So, we have here V2, right? V2 has 8 ohm in common with the V1, so 1 over 8. Then V3, so this one connected also, common is 2 ohm. Then, we'll equate this with all the current entering and leaving, okay? Current entering, this is E, entering or current leaving, okay? And you have to note that current entering, again, that is positive. For current leaving, that is negative. Okay, so we have here current entering the node, that is 5, and current leaving the node, that is equal to 3. Then let's simplify the equation. This is 1/4 plus 1/8 plus 1/2. This will be 2 over 8. Then 4 over 8. This is 7 over 8. Minus B2 times 1 over 8. Minus B3 times 1 over 2 equal to 2. And this is our first equation. For node V2, okay, so let's just write V2 so that you will focus only in this node. So V2, connected resistors are 1 over 8, 1 over 4, and 1 over 2 also. Then look for the nodal voltages that has common resistor. So in this case, we have V1, common resistor is 8. Also, V3, common resistor is 4. And we don't have any current source entering and leaving this node. Therefore, this is equal to 0. Then, let's just rearrange. So, this is V1, 1, 8. V2 is 7 over 8. And V3 is 1/4. And then, equal to 0. And this is our second equation. For node V3, so let's write V3. Then let's look for the resistors connected. So we have 1/2, 1/4, and 1/8. Then nodal voltages that are connected or as common resistor. We have V1 for 2 ohm, and we have V2 for the 4 ohm. And equate this to the current source entering. Entering is 3 ampere. And we also have here the current. So we don't have current source here, but we have voltage source. We have to convert this into current source. So we have 12 volts entering because the polarity is positive. So 12 volts over 8. Yan. Okay. Then let's simplify. So this will be negative V1 times 1 half minus V2 times 1/4. Then plus V3 times 7 over 8. And this will be equal. Yan. So this will be equal to 36 over 8. Ayan. So we have a third equation. Okay, so after we get that, we have three equations to so just the same. Let's just use mode 5-2. Okay, mode 5-2, and we will have the same answer, of course, 10 volts. For V2, we have 74 over 15 volts. And for V3, that is equal to 184 over 15 volts. Ayan. So that is the method by nodal analysis by inspection. Now let's proceed with applying mesh analysis to find the current I here. So our current I is here, this one. So it's in the middle of the two mesh current I2 and I3. Therefore, I is equal to I3 minus I2. Why? Because the direction of I is upward and it's in the same direction with the I3 since I3 is clockwise. Okay? So I is equal to I3 minus I2. Then let's start with creating mesh equation starting with I1. Okay, so this one, let's start with the voltage source. So our current leaves the voltage source in the positive side, so this is 6 minus our 2 ohm resistor connected with or by which I2 and I1 pass. I1 minus I2 minus 10 ohm multiplied by the current that flows rate is only I1 and equal to 0. So this will be 6 minus 2I1 plus 2I2 minus 10I1 is equal to 0. Therefore, this is 6 is equal to 12I1 minus 2I2. First equation. Then for mesh I2, so we have this one. So our current leaves the negative side. So this is negative 8 minus 4 multiplied by I2. Now this one. And then minus 2. So it has again 2 mesh current. But since we are already in the loop 2, so I2 yung una. So I2 minus I1. Then minus 1 ohm for this one. And it is in common for the I2 and I3. So this is I2 minus I3 and equal to 0. So we have negative 8 minus 4I2 minus 2I2 plus 2I1 minus I2 plus I3 is equal to 0. So we have 2I1, negative 4 minus 2, negative 6 minus 1, negative 7, I2, then positive I3 equal to 8. So that is our second equation. For I3, okay, so that's 1. So it leaves to the negative side of 6 volts, so negative 6 minus 5 I3. Then it leaves the positive of the 8 volts, so positive 8 minus 1 ohm multiplied by I3 minus I2 equal to 0. Okay, so the 1 ohm common for I2 and I3. Okay, so let's simplify. Negative 6 minus 5I3 plus 8 minus I3 plus I2 is equal to 0. We have 2 minus 6I3 plus I2 is equal to 0, or 6I3 minus I2 is equal to 2. And that is our third equation. So we already have three equations, three unknowns. So just put it in mode 5-2. Okay, using mode 5-2, our I1 will be equal to, and there, 77 over 234 ampere, or equal to 0.329 ampere. Then for I2, we have negative 40 over 39 ampere, also equal to negative 1.026. And for I3, we have 19 over 117, approximately equal to 0.162 ampere. And since we're looking for the current I here, this one, so I3 minus I2, so that is 19 over 117. Let's use the fraction so that it is more accurate. So it'll be more accurate. So negative 40 over 39. Okay. Then let's go back to the normal mode. 19 over 117 plus 40 over 39. Since negative times negative is positive, so we have 139 over 117 ampere, or that's equal to 1.188 ampere. Now, if you want to solve mesh analysis using shortcut method, again using inspection, okay, so I will show it to you here. So let's consider mesh current I1. So at I1, okay, so let's write I1 here and then look for the all resistors that is in the loop. We have 2 and 10. So this is 2 plus 10. And then let's subtract the other mesh current by which it has common resistor. So just the same concept with the node analysis earlier. So we have here I2, common is 2. So this is I2 multiplied by 2. And equate this to all voltage sources. So we have here 6. So that is 6. Therefore, our equation is just 12 I1 minus 2 I2 is equal to 6. That is our first equation. For I2, so let's just write I2. So take note, if you are in that loop, that is positive. So if you're an I2, your I2 is positive, and other mesh current is negative. So same concept with the nodal analysis a while ago. Okay, so I2, we have here 4, 2, and 1. So I will just write 4, 2 plus 1. Then I1, so I1 is here, so it flows through the 2 ohm resistor also. Then for I3, so it is it flows to the 1 ohm resistor too. Okay, I will delete the ohm. Yan, so that they are all the same with no ohm. Then equate this to all voltage source. We have here negative 8 volts. So our equation will just be negative 2I1 plus 7I2 minus I3 equal to negative 8. Then our third equation will be, so let's write I3, this 1 plus 5, okay, then I2 multiplied by 1, and then we have negative 6 plus positive 8. That is negative I2 plus 6I3 equal to positive 2, and that is our third equation. Ayan, so we now have three equations, three unknowns, and we can just simply use mode 5 to again to find the answer. And of course, our answer will just be the same. So our I1 is 77 over 234 ampere. Our I2 is negative 40 over 39 ampere. And our I3 is equal to 19 over 117. And to find the I, that's just I3 minus I2. So 19 over 117 minus negative 40 over 39. And that is ayan, 139 over 117. That is mesh analysis using inspection.